Hello, my friends of Catry Labs. My name is Olu Montoya. Please welcome to this tutorial. In this tutorial, we are going to do, okay, um, what we are going to do in this tutorial is we are going to work with a MODFLOW model that has a high level of discretization. Okay, when you work with mf6 Voronoi and Voronoi meshes on MODFLOW 6, you can, the advantage is that you can reach um, a high level of discretization. That means cells of really low size, of really low small size, okay, on the area of interest, while in the other areas that are not of interest, the cell size is greater or is bigger. Okay, but this faces also some issues, okay, that we are going to address in this tutorial. Okay, so this tutorial is kind of exploratory of what we are going to do, or about what we are going to, or how to deal with this, um, with the high level of discretization. Okay, great. So we are going to download this file. Okay, so please give me. Okay, so we are going to download this. Okay, so we download this. Okay, and great. And once you have downloaded, you have to place it here in your document folder, and then you are going to extract here with WinRAR. Okay, but if you are using some Windows software, there are some other, but make sure that you have this folder with these other subfolders in this at this level. Document, the folder, and this subfolder. Okay, great. So start our start our Anaconda prompt. Anaconda prompt. The first thing that you have to do is that you have to upgrade your mf6 Voronoi. Pip install u mf6 Voronoi. Okay, so great. Okay, so we have uploaded. So we are in version of mf6 Voronoi 0.034. So and then here cd documents, cd how, okay, and then here we launch Jupyter Lab. Great. Okay, so okay, let's start by creating. Okay, here on scripts, let's go to scripts and let's create a new notebook that is going to be part 0, part 0. Okay, and then say from mf6 Voronoi dot imp utils import list templates and copy template. Okay, length, great. So list templates. Okay, so these are all, and then we are going to copy template of generate Voronoi, and in this case will be drain. What else we can do? Drain mesh. Okay, let's see mesh. Okay, so let's copy the generate Voronoi and copy template of model creation mesh. Okay, so here we have the generate Voronoi and the model creation. Let's go to generate Voronoi. Okay, all right, great. So here we are going to ignore, okay. Then the regional model, the name will be Sandam, San, because it's actually in the place of Sandam in the Netherlands. Okay, we are going to work with 50 and the multiplier will be 1.8, okay? Okay, and this is the advantage that you can go with a maximum discretization of 50 and then you can go from 50 to 1 in less than 10 16,000 cells per layer, okay? Okay, and then for example in the well we are going to reach the 1 meter. Okay, so we are going to reach 1 meter. Okay, and then drain, drain, and then the channels, model GHB. Okay, the last one. Okay, great. So we have inserted our layers. Okay, we generate the point cloud. So, okay, and then we generate the output. Okay, so in the output we are going to have the cell and then we are going to read the cell. Okay, and then we are going to plot the cell. Okay, amazing. Mhm. So these are the cell sizes for the wells. Sorry. Well, the drain is still with 1. That is too much because actually this is 132. Because the drain, okay, I have to kernel, restart kernel, clear all outputs. Why? Because the drain is actually not 1, it's 5. And the GHB is 5, okay? I mean, you can reach those levels, but you will create a lot of cells, so that is why. Okay, great. So we have just the 16,000 cells. Okay, great. And then if you have seen that the code is, I mean, the mesh starts to take much longer to be created. Okay, so we generate the output and then we are going to plot the, let's start our QGIS. So here we have, okay, this is a beautiful mesh, okay, where you have 50, okay, in the parts that are not of your interest, and then you reach the 1 meter. Okay, you reach that 1 meter. Okay, so let's see. Okay, so let's see the in output. Let's see this is the mesh. Okay, so we're here, we reach the 1 meter. Mhm. While outside we reach the 50 meters. Mhm. Great. So we are going to model with this. Okay, so okay, if you want to save this, save image. Okay, so if you want to save image, so we go here, how to reach. So that will be GPG. Okay, and here we can also okay, and then we can give as well a satellite on the back. It's too heavy. Okay, simple line, color. Okay, so here we see as well the mesh with the low level discretization. Okay, so I'm going to export this as well here. Well, PNG, so that will be okay. Great. So we have done this. Okay, so let's go to the model creation. Let's go to the model creation. And okay, so where is the JSON? The JSON is here. Okay, we load the cell 2D. There is no raster. Okay, why there is no raster? Because the elevation is 1 for E in range the NCPL. Okay, because we assume that the surface is flat. Okay, we assume that, and while we assume this, and it has elevation 1 meter. Okay, so there are 5 layers, NP array of elevation. Okay, we don't need this. Okay, the set point is -1, -3, -5, -7, and -9. Okay, great. So this will be on model files, and the executable will be here as well. Okay, it's on the steady state, the groundwater flow, the solver, the Disv, and then the initial conditions are different. So we are going to say IC array of MP zeros of NCPL starting head and AP stop of IC array. Okay, I could place just 0, but okay, this will insert that on an as an NumPy array. Okay, so this is the K is of the send, and the send is the same value, and just the first layer is confined. Okay, great. Storage is in steady. We are not going to put evapotranspiration, but we are going to put some recharge. Yeah. Then the green intersection, and then we are going to define the drains as river. Well, it will be drain, but okay, let's see. Okay, great. So these are the cells, and these will be the drains at elevation minus 0.5. Okay, and then we can plot the drains. So this is our drain network. That is amazing. Okay, great. So then what we do is that we are going to open the GHB. Okay, but okay, from shapely.geometry import multipolygon. Okay, so this is the multipolygon, okay, as a multipolygon. Okay, so as you see, this is a multipolygon. Why? Because we are going to take this multipolygon and insert it as a general head boundary of 0 of elevation. Okay, so this is our general head boundary. Okay, so this is the output. Okay, and then we run the simulation. Okay, so what is the problem here? The problem is that there is an issue. Okay, oops, wait. Okay, 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 okay. Let me check this. Okay, 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 okay. Yeah, okay, okay. Sorry, we we were working with a previous version of the JSON. Let's delete this version. Okay. Yeah, because what we haven't done is that we haven't created the version. Okay, so we open the okay. So we and then we create the JSON dict. Okay, the JSON dict is the one that is created here. Okay, that's amazing. Okay, and then we run everything again, restart kernel and run all cells. Okay, so what we were missing is the generated Disv. Okay, because we were running from a JSON that was generated previously. Okay, so and that was not the point. And the error that will arise is this one. This Fortran error. Okay, maybe you have found this Fortran error before. Okay, as you will say, you can reach me through any social network. Okay, in LinkedIn. Okay, just send me a message. Okay, because I'm really interested that you use this library. Okay, so and this is the Fortran error. And how we overcome this Fortran error and why this Fortran error actually exists. Okay. Mhm. Why this Fortran error actually exists? Okay, the problem of these Fortran errors are the close edges. Okay, here there is some plugins in QAS, plugin validator, polygon validator. We go to close vertices of the sandom. Okay, and then we validate, and then we have some error lines that show us, okay, some size of the polygon that are really, really small. Okay, like this, for example. Okay, this is 0.2 millimeters. Okay, and MODFLOW6 Disv actually do not recognize that. Okay, or doesn't like this or whatever. Okay, so for that, okay, it has to be at minimum of 1 millimeter. Okay, and for that we can fix this. Okay, we can fix this. And how we fix this? Okay, by inserting one point here on the point cloud, and it will generate another object here. Okay, you are not going to see that because these are really small points on the layer. Okay, and actually a person that was working with that actually gave me this issue, and then I work with this. Okay, but you are not going to see that, okay, the difference in the layer like on very intuitive. You are going to see the Fortran error. That is most probably. Okay, so how do we fix that? Okay, there is a part on the template say that if you have a strong difference on discretization or you have encountered a Fortran error, okay, you have to, okay, we are going to restart kernel and clear outputs. Okay, we are going to uncomment these two cells. Okay, great. So we run this, we run this, we run this, we run this. Okay, and this checks the Voronoi quality. Okay, so on the threshold, it checks the Voronoi. The threshold is 1 centimeter. Just remember that the Fortran error arises when the side is less than 1 millimeter. Okay, and then our threshold is for 1 centimeter. Okay, but if you like start to work with threshold of 1 meter, actually you can mess it up. Okay, so my recommendation will be in between 1 millimeter and 1 centimeter. Okay, so these are all these polygons that has a sides with a small with a closed vertex. Okay, and then we fix those short sides. Okay, and then we generate the Voronoi again. Mhm. Okay, so we run this. Oops. Ah, okay. So what is the problem? That the problem is that the sandam is open here. So discard. Okay, the it's almost the same. I mean, it's the same. If, okay, so we generate the JSON again. The number of cells has to be slightly above. So we are, yeah, it's slightly above. I mean, it has to be a little more of cells. Okay, so we generate the JSON. And here, okay, so we rerun this again. Okay, but now we are running this with the fixed JSON. Okay, and now it works. Okay, so finally we can just put 10 meters here of the first layer. Okay, and then we can format the contours because there are a lot of decimals in the contour. Great, so we are waiting for the result. Okay, and here we see the, the distribution of heads, okay, for the wells. And that's it. Okay, so it's really interesting. Okay, so we see the wells, we see the heads, and that is how we can model this high difference in discretization, and then where we can reach, okay, the advantage of the Voronoi meshes, that is to have small cells on the discretiz to have small cells on the discretization on the of certain features like wells or like drains and so on. Okay, and look, the model runs, I mean, you go from 50 to 1, okay, and it runs in only 3, on really in 3 seconds. So this is really effective when you want to do some pest simulation, for example, because it's actually linked to the overall time that the model runs. Okay, so that will be the end of this tutorial. Thank you for being till here. Just to remember that we are a platform for knowledge sharing, and this is if you want to support us, you can take any course of elearning@relabs.com, where soon some Voronoi models will will appear here as well. Voronoi mesh model courses will appear here as well. Have a nice evening. Bye bye. Bye.